Hey Chris,
Yes?
have you ever wondered how an arm on the space shuttle moves?
Not really.
Oh, well, I'm going to tell you anyway. Alright, so first I'm going to start by showing you a basic vector with endpoints at x1 and y1, the vector named r1, and then we're going to rotate it an angle theta, which creates another vector at endpoints x2, y2 with vector name r2. And from these vectors, we can create the equation x2 equals x1 cosine theta minus y1 sine theta, and y2 equals x1 sine theta plus y1 cosine theta. So in 2 dimensions, this matrix would look like cosine theta, sine theta, negative, sine theta, cosine theta.
Oh, so that means that in 3D, on the x-axis, your matrix will look the same as before, but padded by ones and zeros. Meaning that this theta right here is the rotation, or the degree, of your x-axis.
So this is an example of the matrix that we just showed you about how an arm can move around the x-axis. So if we had the matrix before, the theta that Chris was talking about is the degree at which the arm would move about the x-axis.
So that means that the rotation in the y-axis would look like this. With this theta right here, again being the degree at which it rotates on the y-axis.
This is an example of the matrix that we showed you before with the rotation about the y-axis with the base of the arm being on the x-axis, which makes the arm rotate in a circular motion. So adding an extension to this arm really emphasizes what combining these two rotations will do for moving this arm through space.
So rotation in the z-axis looks like the original matrix we were given, except the padding is now on the lower side. And again, this theta right here is the rotation of the z-axis.
Alright, so this is an example of rotation around the z-axis with the base of the arm being on the y-axis. Reviewing what we learned before, rotation about the x-axis will look like this. About the y-axis will look like this. And then the z-axis will look like this. So reviewing, these are just our basic rotational matrices about the x, y, and z axis.